So now we're going to go into a different topic called absolute functions or absolute values. Now let's start with the term absolute. So let's write down absolute. How do we define an absolute value? An absolute value always returns a positive output equal to the input, we can say input number for this sake. Input number. So what does this mean? And it's not exactly the exact definition, but I'll describe it. An absolute value. So let's say we have a value of simply x equals -5. Now, what is the absolute value of this? The absolute value is that is, let's say, let's give it a xa as an absolute, is denoted using these vertical brackets, these vertical straight brackets. And when we plug in this number -15, the output is simply 15. Let's do one more. Very, very simple. Let's go with A. A equals -100. Now, what will be the absolute value of A? It is simply using the square, the vertical brackets, not square brackets. Plugging in our -100, and the output is 100. Now, you can visualize this in various ways. Now, one way to visualize it is that is the distance from the x-axis. Now, let's say we have a simple point. Okay, so let's go with x and y. Let's say my y value here is here. This is my coordinate A. Yeah, it doesn't really matter what's the value. What is important is that it has a negative, let's say -30. Now, the absolute value simply says what's the distance from the x-axis. Now, we can see that the distance is, of course, positive because the distance, even though it's -30, the distance is 30. And this is also the absolute value of, let's say, that point. So to put it into perspective, we can, for example, draw a simple function. So let's go with a nice blue function, which will be a simple x. A simple x, if we recall that it has a gradient of 1, or slope, sorry. When I use the term gradient, it is the same thing as slope. Gradient equals slope. And for those who don't remember, it is the change of y over the change of x. Now, if it's 1, it means that it's 45 degrees. So it looks something like this, going through 0 and going onwards. Now, this is y. However, we understand that this domain right here, I'll highlight it in yellow, this domain doesn't, let's say, exist, doesn't exist. This domain, or the function, this domain, which is exactly, it goes from 0 to y, and I think I'm going the other way around. Yep, I'm going the other way around, so apologies. Let me rotate that. Where's my, there we go. So it is from -infinity up to y and up to 0. This domain right here, which I kind of highlighted in yellow, the absolute function cannot be expressed. An absolute function is, let's say, even impossible to exist in this domain. Let's prove it. Let's evaluate what is the y absolute value, which is of course equivalent to the absolute value of x. Now let's just take, for example, this point. This point, for example, could be -4. Now, of course, a -4 if we plug in -4. So let's plug in and a -4 into our absolute value, and the -4 equals 4. So now the y value at this point is exactly here. If we would plug in -2, again, I think we understand the point, is that it plugs out the positive equivalent value. How does the function look? Well, it goes from here until 0 all the way to -infinity, and then it continues on alongside the blue line. So as we can see, it doesn't exist, and this is the absolute value of our simple y equals x function.